All right, so let's go through. This is the PDF that you did yesterday, page 1. Any questions on this one?
The circle one is not on the.
Sorry?
The circle.
Oh, yeah.
What was
Number
it?
8's not there?
Yeah, it's not on it.
You're doing 1 to 2.9. So starting at 1 and going to 2.9. Wait, sorry, I went the wrong way. You're going to include this one. You're going to include this one.
Oh, not the one that says 1?
No, because it's in between 1 and 2.9. This one says less than 1.
That's like. Okay.
Santi. All right, 3 says your friend has 8 sweatshirts. 3 sweatshirts are green. 1 is white. So you've got 3 green. You've got 1 white and 4 blue. You forgot your sweatshirt, so your friend's going to bring one for you as well as for himself. What's the probability that your friend will bring 2 blue sweatshirts? So you're doing the probability that it's going to be blue, right? And then the probability that it's going to be blue for the second one. So you can either go through and do like all the sample space, green with green with green, green with green, green with white. Like you could go all the way through there, or you could figure out those individual probabilities. What's the probability that it's blue? Or 4 out of 8 to begin with, right? Because the first time would be 4 out of 8. And then if you already picked blue, what's the probability that you get blue again? 3/7. And then you just want to simplify it. So if I was to leave this in fraction form, it'd be 1/2. So that'd be 3/14. And then if it said to round it to the nearest, I don't remember how the answer was written. Oh, like that. If it said to round it to the nearest decimal place, you'd use the calculator. If it said to put in percent, you'd use the calculator. Yeah. So probability blue and then probability white, given you already pulled a blue, right? So this would be 4/8 still. But then there's 1 white left, but there's only 7 total left on that second one. What?
I wrote it like it was independent. I did
Yeah,
4/8.
because they're pulling from the same stack of sweatshirts and they're taking it, right? You take it, he didn't put it back. It would be dependent. Mars.
For percentage, are we gonna have to round yours kind of thing? Like, is it just
It will tell you what it wants you to round to. Like it'll say, like, write your answer as percent rounded to the tens place, or write your nearest percent. There's 10.
multiple choice? Or
No, for your response.
Wait, how many?
10.
No multiple choice.
No multiple choice. Why are you looking at me like that?
My light's staying.
Like I just stabbed him in the heart. That's what that look was. Any other questions on practice 1? Okay, how about practice 2? Yeah?
What does inclusive mean?
Inclusive means it includes it. So like from 1 to, what was it, 1 to 2 point whatever, 2.9, that means you're starting at 1 and including 1. If it was not inclusive, it would start after 1. So it'd be like greater than 1. So it's like greater than or equal to would be inclusive. Questions on 12-2? So 1 independent, 2 dependent, 3, yes, you said 4. So a game show host picks contestants for the next game from an audience of 150. The host randomly chooses a 30-year-old and then randomly chooses a 19-year-old. Use a sample space to determine whether the randomly choosing a 30-year-old first and randomly selecting 19-year-old second are independent. So like if they pull the 30-year-old, it's going to impact who's left, which is why it's dependent. It says selecting a 30-year-old for the game affects the selection of the second contestant. It changes your sample space.
So is it dependent?
It would be dependent.
6.
6 says the probability that a stock increases in value on Monday is 60%. When the stock increases its value on Monday, the probability that the stock increases its value on Tuesday is 80%. What's the probability that the stock increases value on both days of the given week? So this is your and. So it's 60% times 80%, or 0.6 times 0.8. They have no impact on the other, right? The stock increasing on the first one has no impact on that one, so they're independent events. So you just multiply out their probabilities. So that'd be
I wrote the right
0.48
answer.
or
I did
48%.
60 times 80 and then I divided it by 100.
That's the same thing. Yeah. Other questions? 5A. A hat contains 10 pieces of paper numbered from 1 to 10. Find the probability of each pair of the event occurring as described. 5. You randomly choose the number 1. You replace it. So replace it means independent. And then you randomly choose the number 10. So you want to know the probability of getting a 1 times the probability of getting a 10. So the probability of getting a 1 is 1 out of 10. Probability of getting a 10 is 1 out of 10. So it'd be 1 out of 100. Good. Dependent is P of A and B equals the probability of A times the probability of B given A has already occurred. So you'll get 2 of those 3. And you've got to figure out how to manipulate it. If I give you A and B and A, you're dividing A and B by A. If I give you A and B and I give you B given A, you're dividing A and B by B given A. If I give you A and B given A, you're multiplying them, okay? If it's independent, then it's the probability of A and B, but it's just the probability of A times the probability of B. That you don't need the other part. Sebastian. So probability of A and then the probability of A, this goes here, right? So 1 point equals the probability of A, which is 0.34 times the probability of B. You guys, shh. So I divide. If you did it wrong and you divide it the other way, you end up getting the probability bigger than 1, and hopefully that's like an indicator something's wrong, because probability can't be 1 or bigger than 1.